Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with Cambium Networks. Today's host is Bruce Collins, and he is their Senior Director of Product Line Management, and he'll be presenting today. If anyone has any questions, please submit them in the question box, and Bruce will answer them at the end of today's presentation. Bruce, I am finished for now. Thank you so much for being with us today. Please go ahead and take it on over.
All right, well, thanks, Julie, and thanks everybody for joining today. As Julie mentioned, the topic today is our 60 gigahertz CN wave solution. And I know some of you may be familiar with it. Some of you may be familiar with 60 gigahertz in general. But I'm going to give a little bit of a primer or background on what 60 gigahertz is all about, because even if you are familiar with it, there has been a number of changes over the last few years that have really, and quite frankly, in the last year, that have really accelerated the number of applications and the way that you can use this technology. So I'll go through some of that. I'll go through some examples of how customers are deploying this product. And then I'll also go through our latest software release and some of the new features that are in there to give you a sense of how the platform is developing. I'll start with sort of the end in sight here, and this is the kind of a summary of how we see CN Wave stacking up in the marketplace for this solution. And it'll give you a little sense of how it fits in with the other technologies that are out there. So for one thing, our CN Wave product is what we call Teragraph certified. Teragraph is a standard that's developed by the Facebook connectivity team, or now called Meta Connectivity. And they sort of incubated this technology along with Qualcomm, and then working together with companies like Cambium to develop this Teragraph standard that is now being deployed in 60 gigahertz. I'll tell you a little bit more about what Teragraph is all about, but suffice it to say that our CN Wave product is fully certified from layers 1, 2, and 3, which means it's certified at the node level, at the network level, and then at the management level. I'll mention more about that in a moment. This product is really easy to implement or integrate with your current network. So you can integrate it with IPv4 or IPv6. So depending on how you're running your network, you can use your traditional IPv4 for managing and routing, or you can go to the modern latest in technology, which is IPv6. It's really your choice. Under the scenes, or behind the scenes, under the hood, it is IPv6, and it is layer 3. So it is taking advantage of all those latest technologies and making sure that the meshing and everything works quite well. But you can also deploy this in IPv4 or layer 2, and it'll drop right into your existing network. I'll talk about some of the different clients that we have. This is a true distributed mesh networking technology. So we see less than a millisecond latency per hop. And after you have a mesh deployment, the whole network can reconverge or recover within 250 milliseconds, or a quarter of a second. If there's ever an outage within the network and in the mesh backhaul. I'll talk through some of the alignment capabilities and then briefly mention some of the tools that really are built around these radios that make it easier for service providers and enterprise customers to deploy, which is our planning tools, Link Planner, CN Heat, and ANP, as well as our network management, CN Maestro. So that's sort of beginning with the end in sight, and we'll see as I walk through this, you'll kind of see how this all fits together to make our CN Wave solution quite popular in the market today. So one of the first things to think about with 60 gigahertz, especially if you're coming from a background of deploying either licensed microwave or 5 gigahertz or 3 gigahertz, where you're talking about putting radios on a tall tower or a water tower or a cell tower. With 60 gigahertz, the technology and the spectrum requires relatively short range links. So you're talking about maybe a few hundred yards between radios, and maybe for a multi-point and out to maybe a half a mile or a kilometer and a half for point-to-point links. And also it has to be 100% line of sight. You must have line of sight visuals from point A to point B in any of the 60 gigahertz technologies. So what that means is that we're moving from the mast down to the street level. And you can see some pictures in there where these are either deployed on traffic signals, on light poles, the rooftops of buildings. And then you can see here a mounting pole in a parking lot with some Wi-Fi access dialed into it. So really think in terms of moving from the mast down to the street corner. So quite a bit different deployment mechanism and topology. And the other thing I'll point out is the things that have changed. If you saw 60 gigahertz previously, going back as far as 2010, that was based on the 802.11ad standard. And what has happened over the years is that in 2020, this new technology was introduced, which is 802.11ay is the chipset standard, and then the Teragraph that I mentioned previously. And what Cambium has done is taken the 11ay standard, the best of that world, the best of the Teragraph world, and then overlaid our capabilities in beam steering, network management, and the industrial design of the radios, and stacked all that up and built the CN-Wave product. So what you get with the current generation of technology, which is our CN-Wave solution, is you get that better scalability. You'll talk about capacity in the gigabits per second. So if you want to deliver gigabit per second capacity to the home or to the business, multiple gigabits per second and point-to-point links. We have some, with our channel bonding capability, we have over 5 gigabit per second connections. And this is all in unlicensed spectrum that you can just put up wherever you like. You don't need to have any kind of guidance or licensing from the FCC. We talk about the denser deployments you can do, and I'll talk about that a little bit more on the next slide. We mentioned the high availability. Teragraph and the technology underneath the CN-Wave solution is a distributed mesh functionality that uses a technology called OpenR routing, and that does a very high capacity, low latency, and high resilience mesh technology in this product. So lots of different applications. We kind of look at this as a new kind of utility or infrastructure that you can build out anywhere that you would want to connect 2 points, and where you might consider trenching a fiber. You can look at this as an alternative because it gives you those fiber-like speeds, but you can deploy them much more quickly and efficiently. So both you don't have to dig trenches through the ground, and you can get these services up and on the air in a matter of hours rather than waiting weeks or months for the fiber to be deployed. Lots of applications. Now, kind of look at the way these are deployed. You know, when we talk about the applications, they really break down into these 4 topologies. In the upper left, you see a point-to-point link. This is if I just want to connect point A to point B. So this is a very traditional point-to-point wireless communications technology. In this case, we're using our V3000 as a backhaul, and you can go out to about 1 to 1.5 kilometers line of sight range with that point-to-point link. And again, if you have any questions on these, feel free to put them in the chat window. We'll take them towards the end. In the upper right, you have point-to-multipoint. This is again a more traditional hub and spoke model where I have a access point or a hub that I put in a centralized location, and then I can array various client nodes in a radius around that. And in this case, think in terms of a few hundred yards. It may be out with our V3000, maybe out to 500 yards with the V3000, and you can kind of arrange that in a radius or hub and spoke fashion. Where this technology really gets interesting, though, is in the lower left with the distributed mesh architecture. And here you'll see around this urban environment, you have a number of meshing nodes, which we call distribution nodes. And they're just scattered or distributed around the city. And then off of each one of these nodes, you can deploy up to 30 client nodes in that point-to-multipoint fashion. But all of it is backhauled through this distributed mesh. And I have some real world examples of that, but this is really where this technology shines, because you can take advantage of the high capacity in multiple gigabits per second, but you can extend the range and coverage area by using that mesh to do various relays throughout the geographic area. And then there's a special case here for a small cell backhaul, and this just takes advantage of the things like we have a PoE output port, and you can power this off of PoE as well. So a lot of times people will deploy these and co-locate them with either a 5G small cell, or they'll co-locate it with just a Wi-Fi access point. and it makes for a very convenient application, and you can extend that Wi-Fi coverage, backhauling with 60 gig, and then deploying your Wi-Fi with either 5 gigahertz or soon to be 6 gigahertz with a Wi-Fi 6. All of those topologies are really based on 3 different building blocks. On the left, you have the V5000. This is the distribution node. And this is that hub in the hub and spoke, or the distribution or the meshing node in that distributed mesh environment. This is actually made up of 2 sectors. Each sector can talk to up to 15 client nodes, and it can talk to up to 2 additional distribution nodes. And remember, there's 2 sectors in this one. So from one DN, you can talk to 30 clients and 4 additional V5000s. So you can really start to imagine how you would build out the density by connecting to other additional DNs as well as lots of CNs. Now those CNs can be either the V3000, which is our high gain client node, or the V1000, which is the mid gain client node. And that V1000 is about the size of your hand. It's really small form factor. And the 3000 has that dish that gives you, it's about the equivalent of a 2-foot dish, and that gives you a little bit additional range, or quite a bit different additional range that you can cover. Now also these client nodes can be deployed as point-to-point links as well. So you can do a point-to-point from one V3000 to another V3000 and just simply deploy it as a nice high capacity Ethernet bridge. So in addition to all the different options you have for wireless, and 60 gigahertz is a great option for depending on the application and the type of topology you're deploying, where it really comes into play is that is a great alternative to fiber. And this is an example that comes from Facebook Connectivity that says that in a very specific study that was detailed design, shows that the deployment cost is about 40% of the cost of fiber. That's the equipment cost. And you can also get that deployed much more quickly, often in a matter of days or a couple of weeks versus months to deploy fiber, because you have to wait for building permits and trenching and everything else to get done for that more complex fiber plan. So you really can see the benefit, and you can see the much less amount of equipment on the left, a lot less digging and trenching, obviously really no digging and trenching, and then you can get a much lower cost deployment with wireless and 60 gigahertz CN wave. Let me give one more example. This is a scenario where a service provider goal is to deploy coverage to all the 55 homes in this neighborhood. They want to deploy 500 megabit per second capacity or 1 gigabit per second capacity. So they want to offer 2 different service plans. We know the technology, all of these links have to be line of sight. They all have to be less than about 200 meters if we're going to use that V1000. And you can't have more than 15 CNs per sector. So really we look at 2 different ways of approaching this. The first one we'll look at is a traditional hub and spoke, and then we'll look at how distributed mesh can really help make this work better. Now, CN wave can work either way. You can use a hub and spoke or distributed mesh. Just want to show you the differences. In that traditional hub and spoke, if you want to cover all 55 of the homes, you need to put a tower 30 meters high. So you're going to put a 100-foot tower in the central site of this neighborhood. And that's not going to be too popular with the homeowners association, but that's what you need in order to get line of sight to all of these green homes in the area, or the ones that are highlighted in green, or to get to all of the homes, you need to go to a 100-foot tower. If you're just at a 10-meter tower, you're only going to get about 56% or half of the homes. You'll also notice things like the lower quadrant here already has more than 15 homes, so that's going to be over maxed on the sector. So you're going to be having to look at additional sectors here. And then also these nodes out here on the west are starting to be at the limit of the range. And really you have no resiliency, and a single tree could block off a whole section of this neighborhood. And we'll also talk about how if you want to expand this into other areas, you'd have to start thinking about building another tower out in this area or out in this area. So you'd have to replicate this whole infrastructure. But if we compare this to option 2, which is the distributed mesh architecture, you can see here, now I've distributed 7 DNs, or 7 of those V5000s around this neighborhood. They cover all the homes. And no DN is higher than 10 meters high, and that typically means they're, and many of them are just a few meters high, whether they're on a rooftop of a home or on a street light or a traffic signal. The benefits here are most homes are able to see multiple DNs, so you've got resilience from that standpoint. In that, for example, this client node would be able to see both this DN and that DN, so you have resilience there. You have resilient rings and paths in this infrastructure. So if one of these were if this link were somehow to be obstructed, the mesh would automatically reroute and you wouldn't lose any capacity or signal. And you have room to grow wherever the need comes from. So if you had to add some more customers up in this area, you would just add another DN up in this area, and you can start to extend that network into that area. And then again, single obstructions become less critical because you have multiple ways to reach a DN. So it's a very different way of thinking about the network, and we have some tools that help do that with both Link Planner and with our advanced network planning tool that you can reach out to. To somebody like Microcom and or Cambium Direct, and we can help you work through that that design. So that's really a summary of the product and the topology. What I'm going to show you now is a couple of the new features that are coming. We have our release 1.2 is in final beta stages, and we expect to release that 1.2 by the end of the year here, so that you'll be able to download that for those of you that have CNWave already. There's a lot of features on here, and there's a lot of things coming in 2022. This platform was launched at just about exactly 1 year ago. We started shipping this product, and customers started receiving their first units in first quarter of this year. So it's a relatively new technology, and we see it evolving very quickly as a whole variety of different service providers and enterprise companies have started to deploy this product. But you'll see a long list here. I'm not going to go through this in detail, but I want to highlight a couple of the things. Specifically, I'll go through some details on the antenna alignment, and then I'll give you a sneak peek at what channel bonding looks like and this point-to-point failover looks like coming in a release in 2022. A lot of these features were driven by customers like yourselves who are starting to ramp up the deployment, and we're working with things like Option 82, which helps with provisioning systems. We have different ability to drop into your existing radius system, and then also really the scale up and the ability to do high availability when different POPs or point of presence, that topology changes, the network can automatically readjust and recalculate all of its routes very much behind the scenes without any additional configuration or management by the operator. Let me highlight a couple of things. Alignment and beam steering. A couple of things. This is pretty advanced technology with the V3000 and CNWave. It uses beam steering, and it uses high gain antennas, which means that those beams are pretty narrow. With the V3000, that beam width is only about 0.8 degrees wide. So you're kind of looking through a straw or less when you align these V3000s looking at each other. And so what we've done is we've introduced two different techniques. One is in the lower right, there's really kind of a low-tech solution, which is what we call our alignment tube. There's a little mounting bracket on top of the V3000. You can slide that alignment tube in there, and then you can look eyesight, just by eyesight, you can dial in the V3000 and out to about, we're seeing in the field out to about maybe 400 meters, 500 meters, that's adequate to give you a visual line of sight. And then if you want to go further than that, you can use a finder scope, like off of a telescope. You can get these off of Amazon and others. And we have a little mounting bracket as well that you can do that as well. So first of all, you want to align it up visually. Then we have a GUI, or graphical user interface tool, that allows you to dial in the beam. So you can see this graphical indication of where are the beams falling in a left and right, up and down alignment. And you can watch that and dial it in as the installer is at the location doing that installation. And across the bottom here, you'll see a graph of the RSSI, and you can make sure that that matches up to what your link planner plan indicated it should be. So you can make sure that that installation is correct. I'll go ahead and build this slide out. This is another some field examples of how this has been used. And this is actually over in Southwest England, where a lot of our development effort goes on for cnWave, just southwest of London. And in this picture on the left, you can see that that alignment tube is being used. You can't really see out to the other end. It's about 1 kilometer away. It's a farmhouse way out there. I don't think you can quite make it out in the picture. But you start by doing that visual alignment. Then you can go in and use the graphical interface. And in this case, the installer is using our CN Archer tool. Now that CN Archer is a application that runs on your smartphone and can be used to do the alignment as well. So you don't have to drag a laptop up there. You can have that on, tethered on a lanyard, and you can use that to do the alignment. Now that's going to be available here in the first quarter of next year. The actual CN Archer has been extended to support cnWave and this this new tool. So anyway, some nice new features that these are all part of the 1.2 release. And at the end of the day, what you want to do is make sure that as I mentioned, that real world alignment matches what was in Link Planner. So in this case, you had a Link Planner saying that I should be at a neg 43, and the system, or the alignment tool was measuring neg 43, and your Link Planner design said neg 42. So you're within a dB, so all is good. The installer can wrap up and go home because it's done. So you get really nice visual feedback that the installation was done correctly. So let me go through a couple of examples as well. This is in the city of San Jose, California, and it is a deployment of cnWave that is used to deploy high-speed Wi-Fi access to the citizens around downtown San Jose. So if you go to San Jose today and you log on to their public Wi-Fi, your data will be traversing the cnWave 60 gigahertz network. And you can kind of see both on the left is a diagram of the design, and each of those blue dots is a client node, and then these sort of darker dots with the dark center in them is a distribution node. So you can kind of see where the distribution nodes are. And then the yellow dots are the fiber point of presence. So there's 2 fiber pops feeding this network, and they both feed into the area. And then the real world design here coming up in the network management tool on the right shows you the how it pretty much matched the design and is actually live and operational today. So really a great solution. We see this has also been deployed now in a similar fashion in many countries many cities around the world. We also just completed a deployment at YTL, which is out in Penang, Malaysia, which was another high density downtown environment, urban environment. Another example, and this is, so that first example was really for feeding Wi-Fi for public access. This is an example out in Perth, Australia, where a company called Pentanet, and they have a great video online from Pentanet. If you go and Google it, you'll find a great video from the team out there and how they're deploying this. This was a network that is serving residential users. They're offering very high speed capacity links. They offer 250 meg service, 500 meg service, and a gigabit per second service on this network. And this network was really tailored and marketed towards gamers. So it's kind of an interesting approach where they've built this for the demanding game playing user, where they have high demand for low latency and high capacity. And so that's been another rollout that is starting, and they're looking to deploy this. You can see in the network designs they're looking to deploy this throughout the entire Perth metro area. So that's another sort of rapidly expanding deployment. And we have many of these, literally dozens of these cities that are being rolled out now, just 1 year after the initial launch of the product. So it's been quite successful. We have proven deployments, and lots of more information about these example case studies are on our website in different form and fashion. On the enterprise side, interestingly enough, we have several deployments in the rail industry, and also emerging in the oil and gas industry and others as well as just campus environments where they're feeding, like I mentioned before, like the San Jose example, you're just feeding Wi-Fi access. It's also really a nice technology for rail yards, because imagine it's very difficult to trench fiber into an active rail yard. So this becomes quite a nice alternative in deploying multiple gigabits per second across that area. So this is an example where they ran those This is almost entirely a distribution node network. So they use the DNs up and down each side of the rail yard. They have some resilient mesh across the path. And then they're using this for providing video security, video offload. So they offload lots of capacity off of the trains as they come into the yard, and then also for fieldcraft access as they're out working in the field, they can get lots of capacity in that working area. So let's come a couple additional examples. I'll show you a couple things that are coming in the future. This is a feature called the PTP external failover link. So this is the ability to add, if I have a 60 gigahertz point-to-point link, you can deploy a parallel path, whether it's using E-band 80 gigahertz or whether it's using our 5 gigahertz point-to-point solutions like EPMP or PTP 450 or PTP 550. You can run those in parallel. And what that lets you do is it increases the availability of the link, and you can stretch the range even further. So it's a nice feature of giving you more availability and longer range with 60 gigahertz. And that's a feature coming probably about the middle of next year. And then the other one that we're excited about is channel bonding. So this is really going to take the next step up in capacity. Channel bonding consists of both the chipset technology of adding additional channel, a second channel, and bonding it together. And we have a field example or a test site out in the UK going about 5.2 gigabits per second in a channel bonding environment. That's out at about 1.2 kilometers. So I imagine getting 5 gigabits per second unlicensed spectrum. And the other nice thing I haven't really talked about is 60 gigahertz is really, because it is such a narrow beam and it's a relatively short range of propagation, there's much less concern about interference than you see in other bands. So the interference, the noise floor is lower, and the fact that your signal doesn't propagate as far actually works in your favor for self-interference. A couple other things, if you're interested and you want to learn about 60 gigahertz CN wave, we've put 4 really nice videos on our learning.cambiumnetworks.com site. So this is a free site. You go on there and sign up. You can log in, and if you take this course, 60 gigahertz CN wave starter kit, it'll just show you 4 videos, and you can watch these, and you'll get a step-by-step from taking the units out of the box to having a working network in 12 minutes on the point-to-point link. And then if you want to go with the full mesh, it's a 24-minute video. So you really have lots of different approaches to how you would learn how to use this and get you going quick. And to that end, we are offering a CN Wave starter kit. This is available through the end of the year, and it includes a V5000, 2 V3000s, 2 V1000s. So you get kind of a nice set of radios in a kit, and you can go and build this up in your lab. You can take it out to the field and play with it, kind of get your feet wet with 60 gigahertz. And if you watch those videos I showed you on the previous screen, you'll be on your way with this new technology. So that is what I wanted to cover today. I wanted to leave plenty of time for questions, and certainly any other discussion that you might want to have. So Julie, I'll pass it back over to you and see if there was any questions that came in during the session.
Thank you very much, Bruce, for that wonderful presentation. And we do have some questions for you. Let's go ahead and get started with the first one. Let's see, we have an audience member asking, what is the backup for the 60 gigahertz links with Cambium? Is there a 5 gigahertz radio backup?
Okay, so yeah, good question, and maybe that they asked that question before I covered that roadmap feature, but this PTP external failover would be perfect for that the example that they gave, which was using a 5 gigahertz backup. The nice thing about this is the radios have an auxiliary port, the V3000 has an aux port that can provide PoE, so it can power a 450i point-to-point link. It could power an ePMP Force 400 or Force 425 link, and that would run in parallel. And the way the network works is the traffic comes in to the primary, and if the link is obstructed or somehow fades due to rain or some other obstruction, it will swing over to the 5 gigahertz link, and then it'll swing back. And it's using that same routing or meshing determination that it's using internally for mesh, but it'll use that same decision algorithm on when to send the traffic over the 5 gigahertz backup link. So yeah, absolutely, it's coming. If you're really interested in that, I can probably get you onto a beta if you reach out to me in the first part of 2022, and then it'll be in the official release probably out in sort of the second quarter of 2022.
Excellent. Thank you so much, Bruce. And maybe in our next webinar, we can go into some more detail about that as well. Next question here for you. A member here is asking if you could touch again and explain the Terragraph certified meaning.
Sure. Yeah. So if I go back, I'll keep going back. I'll reuse some of these slides. I'll go back to the beginning here. When we talk about Terragraph, the Terragraph ecosystem or the Terragraph standard, what they have done, and again, Terragraph came from the Facebook connectivity group, which is really kind of a technology incubator within Facebook. And they incubated this technology. They did some early field trials. Most of those field trials have now been swung over to Cambium, by the way, because Facebook does not operate or deploy network equipment. But they have those customers like City of San Jose have migrated their entire network over to Cambium. But anyway, as they developed that Terragraph, they defined different layers of certification or compliance. Level 1 is the actual down at the chipset or the node level. And that is the use of this 802.11ay and the way that it uses the air interface. Then there's sort of that link level or network level, and that's how the meshing and everything works. And then there's the network management level. So the ability to do things like our E2E controller and our CN Maestro network management, that all takes advantage of that layer 3 certification. And so Cambium's committed to that Terragraph standard, and we have built the product to comply with that. And if you're looking at other 60 gigahertz solutions out there, you just may want to ask the question, because we believe that we have a pretty leading effort on that right now at this point as far as compliance.
Thank you very much for that, Bruce. Next question here for you, maybe just what you were referring to. The question here is, what's the standard link distance for 60 gigahertz?
So the ranges will be different depending on which radio you're looking at. So I would say the best thing I always recommend is you start with Link Planner, which is the Cambium Link Planner tool, because you can put in actual physical locations and it'll tell you what kind of speed you can expect. And these do that whole adaptive modulation and everything depending on the range and the conditions between point A and point B. And Link Planner also takes into account things like rain fade and how much rainfall you have in a particular area. But if you're just looking for a basic rule of thumb, I usually say that if you're going to have a V5000 to V5000, so like these meshing nodes, we're talking about 200 to 300 meters. And also, if you're going to connect a V1000 to a V5000, we're going to talk about 200 meters. And then if you're going to talk a V3000 to as a client, you can go out to about 500 meters to 600 meters. And then point-to-point links, these go out to about 1.5 kilometers. So all of that detail and estimations are on our website if you go and pull down the data sheets. And then also, again, I'd recommend plugging, if you have an example area, you can plug that into Link Planner.
Excellent. Thank you, Bruce. Next question here for you. Can a person take the certification without purchasing the kit?
Absolutely, great question. That learning. Let me go back to that as well. If you want to take those that course, this is the starter kit course. You can go on learning.cambiumnetworks.com and create an account, and there is a lot of training material on this portal. The starter kit is one. If you want to get full depth training on CN-Wave, you can take a full-blown course that you might expect in a computer-based training course. All of that is available at no charge, so anybody can go on there and you can kind of get a feeling for what this is all about before you make that initial purchase. If that's what you're interested in, you can certainly take all these ahead of time.
Excellent. Thank you, Bruce. I was just going to ask you, if a person goes to your website, I'm sure there's many things they can find, not only many of these trainings, but can we find tech support and customer support as well?
Yeah. So if you go to cambiumnetworks.com, you'll find links to the learning portal, links to the support page. And then the other resource I'd recommend is the community.cambiumnetworks.com. The community is our user forum, and many of our engineering team is on there. Many of our product line management team, including myself, is on there. So if you ask a question, you're going to get a response pretty quickly, either from our support team or one of the development teams. And then even better is you'll be able to share that information with other operators that are deploying the equipment. So lots of people interact on there and learn best practices for how other people are deploying the product. So it's another great resource. It's community.cambiumnetworks.com.
Great, because I was just going to ask you about your community page, and there you have it. You answered that question for us. Bruce, can you tell us about where Cambium manufactures their products, or perhaps most of their products, because I know this could be a very wide open question.
Correct. So yeah, Cambium has many products, and we have many different manufacturing facilities around the world. So this particular product is manufactured in China and then is distributed out of many distribution partners like Microcom, who carries the product here in the U.S. And then depending on where you are in the world, you can get access to the products that way. But they are manufactured in China. We have products that are manufactured in Mexico. We have products manufactured in Taiwan, and we have products manufactured here in the U.S. So depending on the different product, we have different partners around the world that do that.
Excellent. Thank you so much. So with that and the various places that Cambium has, items, product manufactured, would it be sort of safe to say that your shipping and your product line of the way things are, getting to the U.S. in various places, are you having any issues with shipping?
Well, that's a great question. If anyone's reading the newspapers today, you'll hear all about the supply chain challenges that the entire global economy is having. Good news is CN-Wave is available here in the U.S. We have product on the shelf. So if you have interested in getting, for example, one of those starter kits, there's product available. We have a good line of sight to the supply for CN-Wave, and the factories are continue to building, and we have product on the ocean. So the entire supply chain is full, and we don't, we work closely with our distribution channel, folks like Microcom, to make sure that product is on its way and meeting the demand as it grows, and especially as this product is ramping up. So all I can speak to as of today, that's the situation, and we continue to drive hard on that.
Thank you so much, Bruce. Yes, we're all hoping that the supply chain starts, and there is word that the supply chain is easing up and that things are moving along. perhaps not as fast as we'd like, but it is moving along. And we were concerned about that for quite a while.
Yeah, out there in LA, you probably see all of the container ships stacked up off the coast still. So yeah,
Yes,
good.
we do. And the trucking industry is, they're involved as well, and there's a lot of complications involved. But it looks like they're working really hard to get things going and smoothing out the kinks, so to speak. Yep. Also, Bruce, could one find on your website not only technical information, but data sheets and perhaps even information that may show your competitors and what they're doing with like products and that sort of thing?
There definitely is all the data sheets and some application notes, and I'd also recommend that you take a look at some of the case studies that are on there, both video case studies and written case studies. I mentioned we have written case studies for Pentanet, and there's one city of Aurora, Colorado. There's the city of San Jose. We have Alaska Communications. YTL over in Malaysia. There are many, and they keep being there. More are continuing to be added. We just added one yesterday. I think it's Buckeye Mountain, which is an electric co-op that's using CN-Wave plus our Wi-Fi solution. So they're combining our CN Pilot Wi-Fi products with our CN Wave 60 gig as the backhaul. So there's another case study there. So all kinds of good information. And if you're interested in how we stack up against competition, I would just, if you talk to a competitor, I would kind of go through this as kind of a laundry list of how do they stack up against some of these key capabilities that I've listed here.
Excellent, Bruce. Thank you so much for answering all of those questions for us today. And thank you to everyone for attending today's webinar. And if anyone has any further questions, please feel free to contact your sales rep or email us at sales@microcomtech.com. And if you wish to view any of the products mentioned or shown here today, please visit us at www.microcom.us. And please remember, this webinar presentation has been recorded and will be uploaded to our Microcom YouTube channel so you can view it again. Bruce, excellent webinar. Thank you so much for being with us today, and we look forward to touching base with you perhaps in the first quarter of 2022.
All right, thanks, Julie. Thanks everybody for joining.
Thank you. Bye-bye now.